class. Today I will demonstrate to you on the vibration measurement using machinery and also the hand arm vibration measurement for our class on the noise and vibration EMM352. Okay, so in this case we will measure our machinery is grass trimmer. Okay, so the instrumentation we have is the typical petrol grass trimmer lah. Okay, so it have handle, okay, the engine, and this is the shaft lah. Okay, so we can control the power of the machine, okay, using this throttle lah. Okay, so for the measuring device we will use accelerometer. Okay, in this case there are three position of accelerometer at the handle, shaft, and also we will mount it later at the hand. Okay, so this is the accelerometer. Okay, if you can see here. Okay, this is the small size of accelerometer. Okay, and this accelerometer will measure the vibration if we call it as acceleration. Okay, so another device for this experiment we have this the EQ system LMS Kadas. Okay, so also the calibrator. Okay, this is the calibrator. The function is we want to calibrate this sensor lah. Is it function well or not? Okay, and of course we will have this software lah, LMS software system that will capturing the data. Okay. So just now I just already explained to you on the instrumentation that we use for the measuring the vibration of the grass trimmer and also vibration related to the hand arm. So now we are going to more specific on the setting for the measurement software. Okay, so for this lecture we will use this software lah, we call it LMS test lab. Okay, under spectral testing. Okay, so if there's writing here spectral testing is basically for the measurement of vibration. Okay, so in this case, okay, we will have a three input here. Okay, which is I explained before is on the accelerometer. We have three accelerometer that mounted at the handle, shaft, and also at the hand. Okay, so the first step we must set the detailed parameters of each of the accelerometer. Okay, such as the point, location, for example point 1, 2, 3. The direction, in this case we are measuring in this vertical direction. We call it a plus Z direction. Okay, so we are measuring in the acceleration quantity, and of course we must set the sensor sensitivity lah. Okay, so basically all the sensor, okay, in this measurement instrumentation. So all the sensor like the 4 sensor accelerometer we use the signal is in terms of voltage. That's why we need a sensitivity value. Is basically written in the box when we buy the accelerometer. So in this case it's written 2.98. So that is the sensitivity value of this accelerometer lah. So we can convert which can convert the unit of voltage to the acceleration. Okay. Okay, so that value we can insert here. Okay, at the actual sensitivity. Okay. Okay, and then the next step. Okay. We can go to the calibration. Okay. Okay, so this is the section where we need to calibrate our accelerometer lah. Okay. So in this section we can input the unit of this calibrator. Okay, for this calibrator, actually it has a specific frequency. Okay, 159.2. Okay, the unit, the amplitude. Okay, and this is the thing that we need to input lah into our system. Okay, so we have frequency 159.2 Hz. Okay, the level 10, and we will calibrate in 10 seconds of time lah. Okay, so for example, we want to calibrate this accelerometer. Okay, this accelerometer actually is channel to for the input number 3. Okay, this is input number 1, number 2, and number 3. Okay, so we can mount it on the calibrator here. Okay, so we can go back to the screen. Okay, we take channel number 3 lah. Okay, which is point number 3 in the plus Z direction. Okay, so we can first check it. Okay, after check, we on the button of the calibrator. Actually it will vibrate. Okay, okay, so we can push the start button, and the system will detect the vibration lah. Okay, so in this case the level is 10, so it get about the plus minus, which is about 15 of amplitude. So after finish, then we can stop our calibrator here, and we can accept the value lah. Okay, so the same thing we can do for our channel number 1 and also channel number 2 lah, so that we also calibrate. You can see that in the red, blue, and also green color, this all has been calibrated lah. Okay, 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 just now I already showed you on the calibration section. Okay, after we calibrate and make sure that our accelerometer is function well, so now we can start measuring lah. Okay, this is the section where we start measure the vibration data. Okay, so if we can see here, this is a 3 section which is represented each type of accelerometer lah, at the handle, shaft, and also at the hand. Okay, so so this data I just demonstrate to you. Okay, we are using the calibration vibration, which is the frequency at 159 Hz. Okay, so when we push the start button here, so that we can get this kind of time domain data lah. Okay, this is time domain data, and then if we convert to the frequency domain, we can get this type of data, frequency domain. Okay, so if I move this cursor, okay, to this peak, actually it will directly represented the value of the calibrator just now, 159 of a frequency. Okay, so but for the actual case, okay, we are using this hand arm mounting. Okay, where we can put our accelerometer number 3 here. Okay, and we can wear it. Okay, we can wear this adapter to the hand, so you can adjust based on your size of your hand lah. Okay, so there are 3 accelerometer, okay, which is at the handle, okay, at the shaft, and also at the hand. Okay, so where during the operation, for example, okay, if we starting measuring, so that we can measure like this lah. Okay, so you are getting the value at the 3 value which is the input 1 from the shaft, how it can transmit to the handle. Okay, is it the vibration reduced or amplified, and finally to the hand arm system lah. Okay, is it it can be amplified or reduced. But basically in this handle we are already mounted this, we call it adapter. It have a rubber, okay, so that it can absorb the vibration lah basically. And also typically our hand is dampened hand system lah, because due to our hand parameters and structures, so that basically it can absorb vibration lah. But if possible, we are trying to counter the vibration at the machine itself, so that it not give the high level of vibration to the hand arm system. Okay, so that's all for today's class. Thank you very much.